Welcome
to
Emod and Phillips.
Biolab World. You notice how we got haircuts?
They're not matching though. So today we are testing osmosis, which is the diffusion of water from a low concentration to a high concentration. And what I mean by that is when you have a solution with, for example, 20% of a solute and 80% of water, and on the other side of a membrane, you have a solution with 50% water and 50% solute. Osmosis is the property, or the movement of water from the area of low concentration, the 20% of solute, over to the 50% of solute, so that the solutions reach equilibrium. Professor Philip, explain a little bit about the experimental design of today's lab.
So today we will be placing different sucrose solutions inside an artificial plasma membrane, and then we will be placing these artificial plasma membranes inside 200 milliliters of DI water, which will place the concentration, the dilution of the solution on here, and then we'll watch and see how the rate of osmosis changes. Oh, hey there! Welcome to
Emod
and Phillips
Biolab World. So, as before, we were talking about osmosis, and the experiment that we designed and did today is we started off with artificial membranes, and we made them into dialysis tubes, where in this beaker is that tubing that we created.
Now we placed 200 milliliters of DI water
into the beaker,
and we placed the 10 milliliters of the 10% sucrose solution
into the bag, into the plasma membrane, and we clipped it so that we could put it in there without the solution just leaking out the top.
Now,
so the way the water gets into the bag is through osmosis, the process as described before. So you would show the 20% and 40% solutions.
I'm just like I'm only singing one at a time.
Now we measured the mass of all three different solutions of the bags, and then we place them in the beakers, and we will wait about an hour to see the rate of the osmosis and how it progresses.
Okay. Here we have our results of our experiment, where this is the 10% sucrose solution. As you noticed before, you may not notice the difference, but this has become a lot more turgid than it was before. The water from the beaker moved into this, filling it up. Here we have our 20%, which is a bit more turgid. This is a bit squishier. And this is harder. And here we have 40%, which is about to burst. So as we can see, the rate of osmosis was affected by the concentration of the solute. The higher the concentration of the solute, the more water moved into into our bags. So, Professor Philip, what do you conclude about the rate of osmosis? Is it increased with an increase of the solute concentration?
The higher the concentration, the faster the osmosis rate will occur.
I really wouldn't know when it becomes